Today's lesson is on proportions and similar figures. Similar figures have the same shape, but not necessarily the same size. We have a symbol that we use for similar. It's this little squiggly line right there. That means that it's similar to. A scale drawing is a drawing that is similar to an actual object or place. Now, a scale drawing is similar to your similar figures. The scale drawing is a two-dimensional drawing representing something that's out there in real space. Similar figures are more your three-dimensional. So like one of those little matchbox cars compared to a real car. They're trying to represent what the shape of the car looks like. It's just on a smaller scale. It's got all the same proportions. Everything else is the same. When architects are trying to represent a building that they want to build, they make a three-dimensional figure of it. Obviously, it's a lot smaller than the real building, but they get an idea of everything that's and the shapes and the sizes of everything that's going to be in that figure. So those are similar figures. This says in the diagram triangle ABC. The symbol says that we have a shape of a triangle, triangle ABC, and we name the corners ABC, is similar to triangle DEF. Now when you get to geometry, you really focus in on the order of these. So A is in the same spot as B, or as D here. And B is in the top, then E is on the top. Similar to side AB, and we're looking at side DE. So this side AB, you want to focus in on DE matching that side. Now sometimes what they'll do is they'll take this picture right here and they'll turn it around, and then you got to figure out which side matches up. So if you focus in on how this is written, it doesn't matter which direction this is facing, you'll be able to figure out which sides match up. Then we know that from B to C, the second two letters there, from B to C, that matches up from E to F. So E to F right here. Those sides match up. And then our last side here, let's pick blue, from A to C, the first to the last, A to C, and the first to the last, D to F, those sides match up. Now, in order for you to solve these and find a missing side, you have to know which sides match up. And so I'm using colors to represent that, so it's very easy for us to talk about. So you can see that the green sides match up, the red sides and the blue sides match up. Now, if we're trying to find the side like from D to E, that's this one right here. From D to E. Now we have a better idea of which numbers to use. We're going to use the things that are green and the things that are red because they both have some, but the blues actually don't even matter. We only need two sides, whether it's a triangle, a square, a rectangle, a pentagon, an octagon, it doesn't matter. You need two sides to be able to figure this out. So as soon as you know they're similar and you have two sides that match up, you can solve it. So we're not going to concern ourselves at all with the 18 because there's nothing over here. So the 10 and the x are the green ones. What we're going to do is write a fraction using the green ones. Now there's two ways that you can write this. You can do green and green, so 10 over x or x over 10. I always go left to right, so I'm always consistent and it's less thinking every time. So I make a fraction 10 over x. We're going to put an equal sign. We're making proportions here. 16 and 12 are the red sides. Again, I always go left to right, so it's 16 over 12. From there, you're going to cross multiply. So this is one way to set it up. I'll show you the other way. We're going to multiply those numbers together. 10 times 12 is 120. Those two match up, so x times 16 is 16x. And then to solve for x, we're going to divide both sides by 16. And we get x equals 7.5. So this missing side right here is 7.5. Now, as I said, there's a different way you could have set this up. You can write a fraction using those two numbers and another fraction using those two. Now, again, you just have to be consistent. So if I use this, I'm going to say, okay, 10 over 16. Well, since I went 10 over 16, green over red, then in this one I have to go green over red, x over 12. And as you notice, we're still multiplying the 10 and the 12 together. And we're still multiplying the 16 and the x together. So either way you want to solve it, you'll end up with that same answer of 7.5. You just have to be consistent. Go left to right every single time, and then you have less thinking involved then. A sun's rays strike a building and a girl at the same angle, forming two similar triangles shown. Well, you really can't see the triangles, can you? But there are triangles. When the sun's rays are coming down here to cast the shadow, you've got actually the sun's rays forming, not a very good triangle, but a triangle. So there's the actual triangle that they're talking about. Two similar triangles. I'm going to get rid of those for right now. How tall is the building? That's what we're trying to figure out. So you have this information here, you have this information here. We're going to set up fractions. Now, because this is feet and this is feet and this is inches, if this was inches and this was inches, or if this was inches and this was inches, it would be okay. But either these have to be the same or these have to be the same unit in order to be able to solve this. So either these have to be feet and feet, or inches and inches, or these two have to be. That's the only way you'll be able to solve this. So what I'm going to do is actually change them all to feet, and then I'll have everything the same. So 36 inches is actually 3 feet. Because 12 inches is 1 foot. 24 inches is 2 feet. And 36 inches is 3 feet. So I'm going to change 36 inches into 3 feet. Okay, now I know. This is X, this is 15, this is 5, and this is 3. Now, like I said, there's different ways to set this up. When I'm given a picture like this, what I like to do is make a fraction here, make a fraction here, and put an equal sign in the middle. And then my fractions are already set up for me. I've got 5 over 3. So I went height over shadow, and I'm going height over shadow, X over 15. Again, these are all feet, so this one's going to be in feet also. Well, if we cross multiply, 5 times 15 gives you 75. 3 times x is 3x. Divide both sides by 3, and you get x equals 25. And make sure you label it 25 feet, since we're dealing with a word problem. A giant model heart is on display at the Franklin Institute Science Museum in Philadelphia, and it's 14 feet tall. So a model of a heart is 14 feet tall. The heart is an ideal size for a person who is 220 feet tall. About what size would you expect the heart of a man who's 6 foot tall to be? Okay, so we got some things that are in the model. This is in the model, and this is in the model. Similar to, this is part of the person, and this is part of the person. This is part of the building, this is part of the building. So you could make a fraction out of the height of the building and the shadow of the building. And that's what we're going to do with this. We're going to make a fraction out of the height of the heart and the height of the person, and those are both part of the model. So these are both with feet, and this is the height of the heart, and this is the height of the person. So when we make our other fraction, we have to do the same thing, but with real people. So this is all the model, and this is going to be that person, the real life person. It says, about what size would you expect the heart, we don't know the heart, to be of a man who is 6 feet tall. The person's height is 6 feet tall. They're all in feet, so we don't even need to write down the feet. They're all in feet. So 14 over 220 equals x over 6. Cross multiply 14 times 6, you get 84. 220 times x, 220x. Divide both sides by 220. And you get x equals 0.3818 feet. So it's less than half of a foot that the person of a 6 foot tall, that's how big his heart is.